Hello everyone, I am Ziming Wang. This is my report for reading the research performance analysis of medical record exchange model. At the beginning of the research, the researchers introduced the background of the research, the rapid growth of information and communication technology has sped up the innovation of clinical information systems, and also electronic medical record exchange among the hospital can provide more information for physician diagnosis and reduce cost from duplicate examination. In that case, numerous projects and field studies related to the medical record exchange have been conducted. And in this paper, the researchers proposed and implemented a medical record exchange model. They proposed a distributed medical record interchange model in which exchange interface servers that are installed in each hospital to take charge of the intra or inter-hospital EIS communications or networks. To evaluate the system performance, the research applied the Curing theory to model the medical record exchange architecture. After the introduction, the researchers did some literature review before began their project. At the beginning of this section, the researchers outlined several reports address medical information exchange issue based on the standard for electronic data interchange in the healthcare field, called Health Level 7. The report, such as Hutchinson's proposed the HL7 reference model to the integrate clinical and laboratory information and to solve the complex EDI problems, or the report of the integrated database of the medical application platform in HL7, or many other reports. Actually, before the HL7 became the standards, most hospitals have already established their own electronic medical record systems, but these systems only support individual hospitals and don't provide communication or shared resource among hospitals. This is because they don't follow common standards. Therefore, it is difficult for the patient to visit his doctor in one hospital and has his medical record from another hospital available. Thus, HL7 standard is very important. According to the standard HL7, HL7 message is the basic unit of the data transfer between the two systems. When the data transfer between the two systems, the REFI12 message sends specific patient's information from one hospital to another, and the RRI12 is the return message of the REFI12. The RQCIO file is a query message to request medical information for specific patient. The RCIO file is the response message of the RQCIO file. The principal contents of the message are the patient's private information, such as their ID, their name, their date of birth, or other medical information. The reason for hospital information system don't follow a common standard is that in the past is that they strive to protect patients' privacy, even though the demand for patient record exchange has been extensive. Thus, the medical record is exchanged through the network must with safeguards to ensure the data security. The open system interconnection security architecture X800 defines security service in the 5 categories of authentication, access control, data confidentiality, data confidentiality, data integrity, and non-repudiation for protecting the patient's privacy. The authentication survey assures the communication entity to be the one that it is claimed to be. The access control service prevents the unauthorized use of the resource. Data confidentiality protects data from unauthorized disclosure. Data integrity assures that data received are exactly as sent. At last, the non-repudiation measure prevent either sender or receiver from denying the transmitted message. So for access control, besides checking the user ID and password, one way verify the patient and the physician's identification with the insurance IC card and the doctor's digital certificate. Other security services may employ the public key cryptography. The public key algorithm uses a pair of keys that is pre-selected, one key for encryption and the other key for decryption. The most widely implemented public key algorithm is RSA algorithm. The equation of the algorithm is below. In the equation, M is the plain text and C is the ciphertext. The public key is EN and the private key is DN. The next part is related to the researchers' work. Turing models are useful for estimating the system response time and performance. Applying the basic querying theory is the electronic medical record request arrive at the system at a rate of lambda request per millisecond. Queue for serve gets served at a rate of mu request per millisecond and depart. The electronic medical request stay in an average responsible time where the radio of request arrival rate and the system serve relate in the utilization of the system. And the equation below is the relationship between request time and the lambda request and the mu request. The third section is the method of their research work. In this section, the researchers estimated the arrival rate of the request and the server rate of the CPU database and network to model the systems in the querying theory. They simulate the environment of the querying patient record, evaluate the system capacity and the response time, and discuss the system performance. This picture is the system architecture. It is the distributed medical record exchange model. Patient's information is stored in in the distributed medical record exchange model, patient information is stored in different hospital. So in this system, suppose the patient's insurance IC card requires a visited hospital from with one country's medical record, and the EIS in the system are designed for each participant hospital to cooperate with MRISC. The EISC are responsible for communication between the information system inside the hospital and other EIS in the extranet. The MRIC is responsible for the management of EIS address, public keys, and the medical record exchange logs. Let's see the figure. For example, a patient had in his insurance IC card, and his doctor insured his certificate card into the card reader in a client here in this client and computer at hospital 1, and then the client computer sends the request to the EISA. Yes, this computer sent to the EISA for the patient record to another hospital. And after that, the EISA communicate with the EISB from the server center MRISC and request for the medical personal information. And in this process of the communication between EISA and EISB, HL7 standard is needed to encrypt and decrypt the message of the medical personal private information. And after EISA received the feedback from the EISB from the database or the server or other hospital, then it sends the patient's record to the client computer, and then the patient and the doctor can know the record of the patient from other hospital. That's all. That is a simple process of the request for the information. Here's the table. Shows all the abbreviation and description of each queue that shows in this figure. The next part is about the assumption and the estimations. To model the system response time, the rate of the request lambda and the service time 1 divided by mu of each queue are needed to be estimated. Thus, the researchers divided this 9Q into 3 types in table. One is the CPU type, the second is the database type, and the last is the network type. For CPU type, the researchers estimate the server time by developing a HL7 encoding or decoding and encryption or decryption program and execute 1000 loops to calculate the average time. The result is that the system takes about 12 milliseconds to generate an HL7 message and about 5 milliseconds to parse the message. For message encryption and decryption, service time depends on the size of the message. The system takes about 380 milliseconds for processing the RQC IO file and the RCI IO file message respectively. And for the database type, the research create a database table. Yes, the table below is not the database table. About 100 bytes in 10 fields for each record, and then measured the response time of querying record from different table with different number of records. The results of presented in table. The results are presented in table. Yes, the table below is the result of the database type. As we can see, the service time of querying in the database is depend on the total number of the record in the table. As the number of record increase, and then the time of the query increase. The third is the network type. Actually, it is difficult to estimate the network time, so the researchers apply the data of Hedman's, and according to their findings, the minimum theoretical time of sending 5 kilobyte web page through the Ethernet is about 5.4 milliseconds. So the 100 kilobyte internet is about 565 milliseconds, and through the 1 megabit internet is about 129 milliseconds. For the results, the service rate mu and the average lambda can be applied to this equation for calculate the response time R. For example, the survey rate of 100 kilobit internet QHIN is mu equal to 1.295 per second. If 100 medical records are exchanged during each hour, the arrival rate lambda t is 0.028 per second. So the response time is 3.74 seconds. And by using these similar rules, the researchers may estimate the response time in different requests. Different requests raised for each queue. The result of the medical record exchange model are shown in the table in the next page. As we can see, the table of this table, when the number of exchange are increased from 100 to 4,000, we found the response time increased is less than 30 milliseconds, or you can see even don't change in the queue of the QNS, QDB, QNS, QNR, QGS, QGR. It means that the bottle may be similar in this these queues. The other queues increase sharply. We can see is this queue is increasing rapidly. So the research used a different parameter to test that. And in this figure, we can see this for Q, this for Q, figure. We can see the researcher changed the internet to 1 megabit, and we can see the bottleneck of this queue very clearly. That's the result for the implement of the researchers. And for the discussion, in the research, the researchers have developed a model to evaluate the capacity and the bottleneck of medical record exchanges. From the model, the author can find the bottlenecks are in the network backbone or the database of the service center. But for the study, there's some limitations limitations don't have, such as the information system different for different hospital, or the researchers didn't consider about the electronic medical record query from the HIS, or also the memory space of the health insurance card maybe different. And also in this study, the researchers didn't measure the service time of the medical media data exchange, such as X-ray film, CT, or MRI scan. In other words, this implement didn't consider about image exchange. Image is which maybe increase request time. For the conclusion, in this research, the researchers have implemented a prototype system to simulate the medical record electronic model. The function of this system includes the HL7 message generation, parsing, encryption and decryption, and format transformation. And the system simulates the process of the patient request their medical information from the database. The study applied the queuing theory to the model system, simulates the response time, and identified the bottlenecks. And upon the examination of the data exchange capacity of the model, the researchers found the system can process the medical record for about 1,000 patients per hour in the 100 kilobit internet, and 4,000 patients per hour in the 1 megabit internet environment. That's all. Thank you for listening.